Hi everyone. In this lecture on Introduction to Expert System, we shall see what is an expert system with examples, its characteristics, the components and other key terms of an expert system, what is the role of participants in development of expert system, the process of developing an expert system, and why do we need that expert system, and what are its advantages, limitations, and finally the applications of an expert system. Let us see what is an expert system. The expert system is one of the applied areas or sub-areas of an artificial intelligence, and it was the first developed in the year 1970 called Dendril, which is a chemical analysis expert system that was developed at Stanford University. Expert system was the first successful approach of an artificial intelligence system. The other areas of artificial intelligence include natural language processing, robotics, computer vision, computerized speech recognition, and machine learning. So the definition of an expert system is like this. So an expert system is a computer program that is designed to solve complex problems and to provide decision making ability like a human expert in a specialized domain. It performs this by extracting the knowledge from its knowledge base using the reasoning and inference rules according to the user queries. It solves the most complex issues as an expert by extracting the knowledge stored in its knowledge base. The system also helps in decision making for complex problems using both facts and heuristics like an expert. It is also called so because it contains the expert knowledge of a specific domain and can solve any complex problem of that particular domain. These systems are designed for a specific domain such as medicine, science, etc. The performance of an expert system is based on the expert's knowledge stored in its knowledge base. The more the knowledge stored in knowledge base, so the more that the system improves its performance. Let's see an example of expert system. So nowadays where we are seeing whenever we search some statement or a word in a Google search, so it is going to automatically corrects the spellings, so which is a common example of an expert system where at the back end it was been all related or they have been correlated with the dictionary. So if there is any spelling mistakes, so the Google search engine is been reflecting the user, so what is the correct word or a sentence should be there. One more example I can give that if you consider the gaming. So in the area of gaming, how an expert system can be. So we all know, so the chess program, the chess game, what we have been playing. So in that back end, so whenever as per the step moved by the user, so there will be a step taken by the computer with respect to the user's move, and that has all been done because of the expert's knowledge that was being stored as a knowledge, or to say which is been framed as a rules in the knowledge base of that particular game. So this particular game can be taken as one of the example of expert system in that gaming domain. So an expert system is more than a database program. So where a database program generally retrieves or stores the data, unlike where an expert system, so apart from doing retrieving and storing of data, it also infers or give reasons based upon the queries given by the user from the knowledge base. So it is just nothing but an inference engine along with the knowledge base, so makes an expert system, unlike a traditional software or a database, so which is going to have a algorithm with a data structure. Here are few examples of an expert system. First of all, Dendril. So it is a chemical analysis expert system that predicts molecular structure. Mycin, it was the earliest backward chaining expert system that finds bacteria causing infections. It recommends antibiotics and it diagnoses blood clotting diseases. And PXDS, it determines the degree and type of lung cancer. CADET, it is a diagnostic support system It identifies the cancer at the earliest stages. So all these are the medicine domain related expert systems. Then POMing. It is a apple orchard management expert system that advises farmers when and what to spray on apples to avoid infestations. Then COMAX. It is a cotton crop management expert system that predicts crop growth and yield in response to external weather variables, soil physical parameters, soil fertility and pest damage, etc. So these are the various examples of expert systems that are related to agriculture domain. What are the characteristics of such an expert system? The high performance. Expert system solves any complex problem of a specific domain with high efficiency and accuracy. That's why they have been high performance. They are understandable. They respond in a way that can be easily understandable by the user. It can take input in human language and provides the output in the same way. So that's why they are understandable. The expert systems are reliable in generating an efficient and accurate output. So that's why they are reliable. Highly responsive. The expert system provides the result for any complex query within a very short period of time, which makes them very highly responsive. We shall move on to the basic architecture of an expert system. The basic components of an expert system are knowledge base, inference engine, and user interface. The human expert here provides the required knowledge and facts related to the specific domain, where the knowledge engineer is the one who represents this information using any of the knowledge representation methods, and the end user is the one who inputs his queries and get the solution or advice from this expert system. Now we shall look into what is the function of these basic components. First, the user interface. The user interface is the most crucial part of the expert system. It is a graphical user interface that helps the user to communicate with the expert system. This takes queries as an input in a readable format and passes it to the inference engine. After getting the response from the inference engine, it displays the output to the user. Then inference engine, also called as rules of engine. The inference engine is known as the brain of the expert system, as it is the main processing unit of the system. It applies inference rules to the knowledge base to derive a conclusion or deduce new information. It helps in deriving an error-free solution of queries asked by the user. With the help of an inference engine, the system extracts the knowledge from the knowledge base. Inference engine uses the below modes to derive the solutions. So one is forward chaining and the other one is backward chaining. So what is this forward chaining? It is a strategy of an expert system to answer the question, what can happen next? Here, the inference engine follows the chain of condition and derivation and finally deduces the outcome. It considers all the facts and rules and sorts them before concluding to a solution. This strategy is followed for working on a conclusion, result or effects. For example, prediction of share market status as an effect of changes in interest rates. Then the other one is backward chaining. It is a backward reasoning method that starts from the goal and works backward to prove the known facts. With this strategy, an expert system finds out the answer to the question, why this happened. On the basis of what has already happened, the inference engine tries to find out which conditions could have happened in the past for this result. This strategy is followed for finding out cause or reason. For example, diagnosis of blood cancer in human. For example, you can take one more example. So when we approach a doctor, so with a problem stating that there is a food poison. So automatically the doctor asks the question, so what you have ate yesterday night or yesterday. So then we will say some food we have in the restaurant outside. So then the doctor going to conclude that, so that might have created this problem of food poisoning. The next component is knowledge base. The knowledge base is a type of storage that stores knowledge acquired from the different experts of the particular domain. It is considered as big storage of knowledge. The more the knowledge base, the more precise will be the expert system. It is similar to a database that contains information and rules of a particular domain or subject. One can also view the knowledge base as a collection of objects and their attributes, such as lion is an object and its attributes are it is a mammal, it is a domestic animal, etc. So what are the components of this knowledge base? So this knowledge base has two components, one is factual knowledge and the other one is the heuristic knowledge. So the knowledge which is based on the facts and accepted by knowledge engineers comes under factual knowledge. And the knowledge based on practice and the ability to guess, evaluation and experience comes under heuristic knowledge. The other key terms in expert system are knowledge engineering. The process of designing an expert system is called knowledge engineering. It consists of three stages. Knowledge representation. It is used to formalize the knowledge stored in the knowledge base using the evidence rules and other knowledge representation methods. Then knowledge acquisition. It is the process of extracting, organizing and structuring the domain knowledge, specifying the rules to acquire the knowledge from various experts and store that knowledge into the knowledge base. Then knowledge validation. It is the testing of knowledge of expert system whether it is correct and complete or not. Before going to the process of development of an expert system and the roles of participants, we shall look into the terms domain, problem domain and knowledge domain. In general, the first step in solving any problem is defining the problem area or domain to be solved. An expert's knowledge is specific to one problem domain like medicine, finance, science, engineering, etc. The expert's knowledge about solving specific problem is called the knowledge domain. The problem domain is always a superset of the knowledge domain. For example, infectious disease diagnostic system does not have knowledge about other branches like surgery. So for better understanding, so consider cardiologist may not suggest for queries related to skin. So here medicine is gonna be a problem domain and the various specializations under medicine like cardiology, neurology, ophthalmology, orthopedics, etc. comes under knowledge domain. This shows that so the expert system reasons from knowledge domain. Let us look into the participants who will involve in the development of an expert system. There are three primary participants in the building of an expert system. The experts. So the success of an expert system depends on the knowledge provided by human experts. These experts are those persons who are specialized in that specific domain. Then knowledge engineer. Knowledge engineer is the person who gathers the knowledge from the domain experts and then codifies that knowledge to the system according to the formalism. And finally, the end user. So this is a particular person or a group of people who may not be experts and working on the expert system needs the solution or advice for his queries, so which are complex. Now we shall look into the process of expert system development. First, the identification. So determine the characteristics of a problem. Second, conceptualization. So finding concepts to represent the knowledge. Knowledge engineer and domain expert work in coherence to define the problem. Formalization, designing structure to organize the knowledge. Implementation, formulation of rules. The knowledge engineer translates the knowledge into computer understandable language. He designs an inference engine, a reasoning structure which can use knowledge when needed. And finally, testing. It's nothing but validation of rules. Why do we need expert system? Though we have human experts in every field because of the following reasons. First one, no memory limitation. It can store as much data as required and can memorize it at the time of its application. But for human experts, there are some limitations to memorize all things at every time. Second, high efficiency. If the knowledge base is updated with the correct knowledge, then it provides a highly efficient output which may not be possible for a human. Third, expertise in a domain. There are lots of human experts in each domain and they all have different skills, different experiences. So it is not easy to get a final output for the query. But if we put the knowledge gained from human experts into the expert system, then it provides an efficient output by mixing all the facts and knowledge. Fourth, not affected by emotions. These systems are not affected by human emotions such as fatigue, anger, depression, anxiety, etc. Hence, the performance remains constant. Fifth, high security. These systems provide high security to resolve any query. 6. Considers all the facts. To respond to any query, it checks and considers all the available facts and provides the result accordingly. But it is possible that a human expert may not consider some facts due to some reasons. 7th, regular updates improve the performance. If there is an issue in the result provided by the expert systems, we can improve the performance of the system by updating the knowledge base. What are the advantages of such an expert system? Availability. They are easily available due to mass production of software, and these are highly reproducible. Then less production cost. Production cost is reasonable. This makes them affordable. Then the next one, speed. So they offer great speed to respond to a particular query. They reduce the amount of work an individual puts in. Then less error rate. Error rate is low as compared to human errors. Error possibilities are less if the knowledge base contains correct knowledge. Reducing risk. So they can work in the environment dangerous to humans. And finally, steady response. They work steadily without getting emotional, tensed or fatigued. What are the limitations of such an expert system? The response of the expert system may get wrong if the knowledge base contains the wrong information. Like a human being, it cannot produce a creative output for different scenarios. Its maintenance and development costs are very high. Knowledge acquisition for designing is much difficult. For each domain, we require a specific expert system, which is one of the big limitations. It cannot learn by itself, hence requires manual updates. Finally, the applications of an expert system. So expert systems are applied in various domains, and here are the list of expert systems from those various domains, of which I shall explain you an example of expert system. Consider the loan analysis. So we all know that, so if you want a loan, we will be approaching the bank, and there, so the executive, so who is going to analyze how much amount of loan can be given based upon various factors. So he poses a questions like, so what is the monthly salary of ours, and where we have been working, and if you have been using a credit card, so what is the CIBIL score. So likewise, so there will be a number of parameters are being asked from the person who is approaching to get a loan, and this information is being fed by the executive in the system in a software, or that is being said to be an expert system, behind which, so all these informations are being taken as facts, and that are being correlated with the rules in the knowledge base, and finally this system is going to conclude how much loan can be given. Likewise, so these are the various applications with respect to various domains in an expert system. So finally, expert system is a software or a computer program, so that gives the output for a complex queries with the help of inference engine and knowledge base, so that actually replicates or imitates how the human experts are going to do the same job in that specific domain. Thank you.